Oh, hey. I had this idea for a game. It's like this guy, and he's like, pew, 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 pew. And then these other dudes, they're coming down at him. So we're gonna make that.
Alright, this first video is not going to be a super deep dive into programming. It's going to be more about how I start a new project, a little bit about the build process, and a little bit about how I do my editing on the PC side and then get that over to the actual Apple IIgs. But the first thing I want to do before I even mess with any code or environment setup is check out my proof of concept a little bit. If you saw my awesome drawing earlier, you might have seen that there's sort of a road that comes down at an angle. And I was thinking that it would be very easy to detect when somebody reaches the boundaries of this road if I made the road fall on even boundaries for the memory on the Apple IIgs. And if you're not familiar with it, it's actually 2 pixels horizontally for each byte of memory. So what I've done here is I've drawn 2 pixels, gone up 1 row, and then drawn 2 pixels, gone up 1 row, and I'm kind of copying and pasting it. And I could have done this another way, but you know, it was easy enough to do in Photoshop just to make sure that if I did it that way, the actual gameplay area would be big enough to kind of match that drawing and my overall vision. And the other reason, like I said earlier, that I'm doing it this way is because if I do it on byte aligned memory locations, then it should be a really cheap calculation to determine when somebody's hit the boundary of this non-rectangular area without doing some more complex, Bresenham type calculation. Anyway, it looks good. You don't need to see me do all of this, so I've sped it up a little bit, and I'm just playing with maybe making it a little bigger or smaller. And I'll throw in maybe a little guide just to kind of make sure that overall the size would match what you would want for the size of your player on the screen. It looks pretty good. Looks like my awesome drawing that I did on paper. I'll go ahead and actually create 2 sprites of this guy in a running animation just so we have it for down the road. Even though I'm not going to use it today, I'm going to really speed it up now, so bear with me. This is kind of the part of the design process, but it's not necessarily something you need to watch if you're interested in learning how to program for the 2GS. I look at a little reference art to see how's it look when a guy runs away, but ultimately I have no artistic ability anyway, so I just need 2 frames of an animation, and I'll give it an outline or something to help it stand out a bit more, I suppose. I'm not going for perfection here. I am considering this placeholder art that we'll replace in the final version of the game, supposing there was one, but really it's also not what this video is about. We're going to talk about programming for the Apple IIgs. So overall, I think my art looks like the playfield will be the right size. Everything looks good. And before we do anything else, let's start talking about the actual development environment. Unfortunately, I'm a bit of a slob and I just have directories everywhere, and I'm going to be borrowing from some other projects that are in these directories, and hopefully you can follow along. I'll try and speed up when it gets too boring and slow down when I get to the important parts. So first I'm going to make a directory for our game. We'll just call it shooter, and we'll go into the shooter directory. Next thing I'm going to do is actually go to a project that I have uploaded to GitHub from the last year's Kansas Fest that has a bunch of things I had prepared for a programming course for the 2GS. And the first thing I'm going to do is check out my gslib project. It has a couple of super high-res graphics routines and some font routines that I'm just going to borrow just as a skeleton to get started. I'll get into our own programming for this game, but there's nothing wrong with having some code to help you bootstrap your project just to really get into it very quickly. I'm cleaning up the Git metadata, and now we'll talk about editing and how I set up my Vim editor to be able to edit on a Mac or Linux or even Windows box with Vim and get good formatting and how I get that onto the 2GS. And I actually have a project for that on GitHub too. And I need a couple of things. I need the syntax highlighting file. The syntax highlighting file makes it so that Vim, also known as VI, I use Vim, the newer version, Vim allows you to do syntax highlighting, which most programmers are familiar with, but you need a file that defines what your syntax contains. And as you can see here, you just basically take my Vim syntax file and put it into your own vimrc directory in the syntax area. Now I've already done that on my box, but I'll still show you what it looks like. You can see it's got all of the compiler keywords in there, opcodes, etc., so that it knows how to color these. And I didn't create the original 6502 version. I got a copy of that and extended it. So what I need to do is tell my vimrc file, hey, if it's a .asm or a .s file, that's actually going to need to use my syntax highlighting file. And that's about it. Now Vim knows to use our syntax highlighting for Apple IIgs or Apple II assembly, really anything that ends in .asm or .s. But I missed one thing. I forgot to tell Vim that there's something else it has to do for those files, which is set my indentation much wider, because I like long function names, long subroutine names. But before I fix that, I'm going to jump around a little bit, and we're going to find this font library. I want to make sure I get the right files. I'm going to copy from my gslib checkout that I did earlier a little skeleton program that just prints out a message and the required font file, which is really just, a font that I made by typing out a bunch of defined byte statements. Okay, now I'm going to rename it, and we're going to call this game.s. So it's a basic shell of a System 16 application that can draw to the screen and do a couple things. And don't worry, it may seem like I'm cheating for starting from that SHR hello, but we're going to really write everything from scratch. It's just good to have a starting point, and the actual launch and quit code doesn't need to be changed. That's pretty much boilerplate GSOS/ProDOS 16 calls. Okay, I'm done making silly changes here. So let's fix the indentation issue. I'm going to go back to my Vim project on GitHub and see what I forgot. Yes, I use a special file in the FT plugin directory that says something different. The syntax file just does the highlighting. This FT plugin, you can set specific Vim settings for that file type. So that means I can say, hey, when you load an assembly file, go ahead and set the tab stops to something much wider. And I'll show you how I do that now. Unfortunately, I need to recheck out my project. I deleted it because I was trying to keep things clean, but I got a little ahead of myself. And in my Vim directory, in my home Vim directory, I need an FT plugin directory. And I'll show you what the file looks like. You can see that basically I just set up wider tab stops specifically for those files. And that's it. So I go ahead and copy that in there. And now, voila, you can see we've moved over very far into the 14th column. And for me, that's much better. I've got plenty of horizontal space on a modern monitor. I'm actually more concerned about vertical space, but anyway, you can see that we've got an editor that has syntax highlighting now, decent spacing, and I like really long names, like I said, so there's an example of one of the labels, the set palette color, and yes, that's longer than my indentation, but I don't want to get too crazy with it. So you can see that really does allow me to have quite long names, though, without going over into the next column. Now, I'm going to take a second and scavenge through some other projects that I have laying around. And I'm going to take some things like the script that I use to put things into a ProDOS image, and also a link to GSport so that I can launch it from the command line, and you can use whatever emulator you like that can launch from the command line. I use either IIgs or GSport, which is the derivative version of that. So you can see I have a little script, and I could make it an alias, but I just copy it wherever I need and make it executable so that it's explicit to anybody trying to follow in my tracks, or if I wanted to ever commit that to a repository, it wouldn't be some magical command they wouldn't know about. They would realize, oh, hey, I need this to point to my GSport. I also have sort of a default GSOS image, and I believe it has Merlin on it, not much else. So I'm going to copy that hard drive image into my shooter directory. I need Apple Commander. I use that to script the disk creation. And you can also use 2 Pro, which comes with kegs, and I have a special version of that if anybody would prefer not to use Apple Commander, but Apple Commander works all right for me. There's a couple of things I wish it had, but I'm too lazy to really switch very often on these things. Okay, so I'm going to copy my make input script from another project that I really should finish someday because it's pretty cool. Okay, so I'm just cleaning up a little bit more and trying to stay organized here. I'm going to speed up so you don't have to sit through all of this. Okay, let's look at the make input script that I copied from another project, like I said. And it uses Apple Commander, like I said. We'll create the name of our disk image and what it's called in GSOS, shooter, obviously. Just trying to keep it simple. And I have some examples here for different file types, bin, SCR, which I believe is some graphics format, LZ4 as a bin. Now the important part. This is the meat and potatoes. I do a loop through these files, which are obviously source files, and I do some translation. I translate the new lines to carriage returns. I translate any tabs into spaces, which we can fix later in Merlin, even if there's a bunch of spaces. And to do this translation, I'm using this tr command, which is available on Linux and Mac OS, and I'm sure you can find an equivalent for Windows. And that'll translate from one character into another, as you can see in the command there. And then I run Apple Commander to stick each one individually, the converted version, into a disk image. So that converts my, standard Unix format text file into an Apple-friendly format for Merlin. And I need to make a couple of changes here, make sure it's writing to the right disk image. This should really be using more variables. You can see this is a sloppy mess, but it's also very explicit. You can see exactly what's going on here. So if anybody wants a copy of this, I can certainly provide one. I don't have a really clean version anywhere, but that's really all I'm doing. I'm scripting Apple Commander with a couple of, like I said, translations that do the new lines and carriage returns and tabs and spaces, and that's about it. I do some other things on occasion for certain special files like graphics or sounds, kind of like what you can see above. I'm going to go ahead and turn some of these into variables. I feel bad that it's so heavily reliant on just hard-coded magic stuff here. Now I'll make my script executable so I can just type it in at the command line to run it. And I made a couple of mistakes. I forgot to create my build directory. I need that. And I am not pointing to Apple Commander correctly. I put it in that tools directory. So I should really make that a variable just because I shouldn't even be copying Apple Commander around to each new project I create. So let's just point to the version in our tools directory, and then we can reuse that variable. And if we ever change it in the future, oops, I missed one, we can just change the variable, right? That makes a lot of sense. So I apologize for not explaining earlier, but this is just a bash script, and it runs commands as though they were typed from the command line, minus some variables when you're doing the scripting. And oops, I forgot to make it a relative path. So excuse me. Let's go back up and add the period there to make it a relative path, and now it should build our image. Great, let's verify that, check the directory real fast, and sure enough there is shooter.po, which is an 819,200 byte file, which is exactly the right size for an 800K disk, so that looks good. I still need to get a config file for GSport. I haven't really set it up for this project, and I just put a different config in each little project I do, so it can use the same GSport, and it can even use the same ROMs, but I like to keep a local config file. So I'll try and copy one from another project. Ooh, here's a cool one I should really finish someday. And here's another one. Okay, I'll copy a config from just another project and we'll edit it. What I want to do is put in our shooter disk image and boot to GSOS. I don't need this other one that we don't even have. And I forgot to copy in the ROM. Let's not copy it. Well, should I copy? No, let's just point to that one. We don't need to keep copying stuff around. All right. Now you can see I've got my disk image with the 2 source files. We'll load one in Merlin, and I'll show you the spacing is a little off, but you can type this fix command, and it fixes our indentation and fixes any extra spaces. So that's a good way to get your source code in there, without having to worry about perfectly formatting it on the host side or your modern computer side, I guess. But I'm going to do one last thing. I'm going to show you how to set the tab stops to match the 14 column tab stop that I'm using on my Vim editor. So if you look in your Merlin directory in, I believe it's the source directory, yep, there's a parms file. And we want to edit our tab stops. Is that, no, that's not it. I'm sure this would be easier if I would just use the find function of Merlin, which is OpenAppleF, and oh, there we go, sure enough. Okay, so let's go ahead, and there's 3 tab stops, which, obviously opcode and comment, and I don't know what the third one is. Oh, I'm sorry, opcode, operand, and comment. And I'm just going to set the first one to 14 and add, what is that, 5, 6 to the other guys as well. And you need to actually assemble this, and that will create the new binary parms file that Merlin uses when it loads. So, you have to edit that file, then you also have to assemble it. So I'm going to quit back out to the Finder, and then just kind of double check here. Let's make sure that it did write a new parms file out, and it looks like, oh, there it is, right in front of me. And sure enough, it is from 2014, April 6th. So that is a new file. And let's load our source again and see how it worked. That looks better. Let's use our example from earlier. I typed out that set palette color in Vim, and it went, yep, exactly 1 character into that column, so that's great. Now the code I took from that GitHub project just spits out a string. I'm going to go ahead and change the string. I made this for Kansas Fest last year, and we'll have it say, welcome to Shooter. And I know it might seem a little bit like cheating using that GitHub project, but trust me, we'll write plenty of code for the actual game part of this. Really, all this is a shell with some font routines and the ability to turn the graphics modes on and off. So I link that using OpenAppleO and then typing in the command link, and it created our game system16 file. And it says, welcome to Shooter. Cool. We have a GSOS compatible application. It quits back to the Finder. It seems to be fairly well behaved, so we'll quit out of GSPort. Now I only changed that file within Merlin, so my changes aren't here in my host system, my local Mac laptop here. So I'm only really doing one way at this point. I have made some utilities to grab my source files back out of the GS image, and that's good to have. But at the same time, I rarely use it. I almost always do my code on the host and then push it into the GS and make changes that way. So I have my own version of something like a GitHub, which is a source code repository called GitLab. And I'm going to create a new project. And this is my favorite thing about developing on these modern systems for retro computers, is I can use modern development techniques like source control. I'm using Git, but you could use SVN or whatever you like. And I'm going to use Git to create a new repository. I just type git init, and this creates a local repository. I'm going to add the source files that we just created, our game.s, our font.s that we copied in, and that make input file. And you can do a git status to see what's ready to commit those green files. All right, let's commit them. So our initial commit, just not really worried about all the Apple Commander and all that stuff, just the things that we've actually created for our project for right now. And then I'm going to add my remote origin, which, if you're familiar with Git again, you have a local repository, but you can push your changes up to a remote origin. And now I've pushed my changes. You can go back to my website here and see that I created this new project 2 minutes ago, and just now I pushed up my code changes. And if we click on that to view what this project looks like, you can see that because I'm expanding tabs for VI, the source code There's our make input, which has syntax highlighting. And our source code, even though it doesn't have the Vim syntax highlighting, is still quite readable, and the spacing looks great. And of course, my favorite thing is being able to track my changes over time. So let's make a quick change. We'll just do something trivial just for the example. I'll go ahead and let's just add another line to our comments at the top. Add a little version. Then we'll commit this. You can see the diff there. It added that one line. So Git does really well. You know, it doesn't care if it's assembly or C or what language. And we'll commit our modified game.s. Added version number, that's going to be our commit message. And I'll push that back up to our remote repository again, just to see what happened, if it changed. Oop, that was a little too fast. Refresh the page. Aha, there's our latest version. And I can click on the little version hash there, and sure enough, it shows that I added a line. So that is pretty awesome for me. It really allows me to have a lot of control over the changes and tracking when I introduce new bugs, which I tend to do a lot. So one last change here, just to show you how quick it is. So now that I've got this set up, this is basically how I would edit my source. Let's say I wanted to change that string. I would remake my disk image, reboot GSOS, go into Merlin, go to that drive, load my source, and compile it. I could boot straight into Merlin, like I said earlier, but even with this build process, it's pretty speedy, especially when you consider what it used to take to even boot from a SCSI hard drive back in the day. And that's it. Thanks, you guys. We'll get into code next time on some joystick routines and playing with those sprites that we created at the beginning. All right, take care, and I'll see you next time.
That was weird.